So for section 10.6, we're going to be finally solving. So we're going to be given equations, and we have to undo the radicals. To do this, I'm going to do inverse operations. See, I see x being multiplied by 3, added by 4, but then it's also stuck in this radical, right? So the idea is I can't touch any of that until I deal with that grouping. This exponent right here is getting us in trouble. And you're like, I don't see an exponent. Well, an exponent is basically related to a root. We've had that already. So to undo a root, we use an exponent. They are inverse operations of each other. Okay? And we've already seen that the square root is the same thing as a 1/2 power. So we've seen that. So the exponent and the root are related. So we have to deal with that first. We're going to isolate that radical. We're going to undo it with the power. Then we'll deal with this adding, subtracting, multiplying, dividing. We have to deal with that grouping first. Okay? So since that root is really the last thing that's happening to x, all of this multiplying and adding is happening inside the group. We have to deal with that first. So to undo a second root, we use a second power. If I do it to one side, do it to the other, the square root and the square cancel, leaving us with 3x plus 4 is equal to 8 squared, 64. See, this is way more power than we had in the last section where we had to multiply top and bottom just to deal with radicals. Here, I'm dealing with an equation, which means I could do anything, including squaring both sides. So at this point, inverse operations, we undo the adding by subtracting. So that 3x equals 60, dividing by 3, x must be 20. Take a second, check your answer on these. So if I check that, 3 times 20 is 60, plus 4. You end up with the square root of 64 equals 8, which is true. There will be some extraneous solution, so do make sure that you check your answer. Okay? Next one. Do not square this. The first step said to isolate the radical. See, all of this is happening inside this radical, and this minus 9 is happening less. If I do inverse operations, we have to deal with that first. If you want, I mean, technically you could square this side, but you'd have to be distributing this whole mess. It's not worth it. Isolate the radical first. Okay? So we're going to add the 9 to do that. So the square root of 5x plus 1 equals, how about 4? Now we undo that radical, undo a second root with a second power, leaving us with 5x plus 1 is equal to 16. Subtracting 1, 5x equals 15. Dividing by 5, x equals 3. Maybe. Don't forget to check. 5 times 3. 15 plus 1 minus 9 should equal 5. The square root of 16 minus 9 should equal 5. 4. Oh, good thing. I was like, something wrong. This should be a negative 5. 4 minus 9 equals negative 5. Negative 5 equals negative 5. So don't forget that on these, I'm going to encourage you to check your answer. If it's a homework question, type it in, hit enter. But on the test, you're going to want to make sure that you check those answers. Well, what do I do when I have multiple x's? See, I can't just ask what's happening to x when I have multiple x's. But the problem is, I can't do anything until I've dealt with this radical. So how do I undo that? Well, it's already isolated, so we're going to square it. The left side's easy. The radical and the squaring cancel, leaving us with just 4 minus x. The right side, be careful, is not x squared plus 4. We've had this conversation before. It means x plus 2 times x plus 2. Distributing that, you should get x squared plus 4x plus 4. Well, how do I solve this? Well, this is quadratic. So we have chapter 6 coming back. meaning I want ax squared plus bx plus c all set equal to 0. I've got kind of ax squared plus bx plus c. I just need to get that equal to 0, which means I'm going to add this over and get 0 is equal to x squared plus 5x. I'm tired of people telling me this is not factorable. It doesn't fit one of our regular quadratic factoring, but it does follow our first step. Our first step with factoring is to look for any like terms. And these both have what in common? Pull that out. So we factor equal to 0, and then we set each group equal to 0 and solve. Our first group, x equals 0. Our second group, x plus 5 equals 0, so that x equals negative 5. Keyword here. You need to make sure you check these. So go to the side and check 4 minus 0, that's not too bad, would be the square root of 4 is equal to 0 plus 2. 2 equals 2. 0 is fine. Check the negative 5. 4 minus negative 5 becomes 4 minus negative 5 becomes 4 plus 5. So the square root of 9 is equal to negative 5 plus 2. The square root of 9 is equal to negative 3. Since that square root was already in the question, then we end up getting 3 is equal to negative 3, which is not true. So that makes that negative 5 extraneous. So be very careful, okay? If we had put that square root in, we would have had a plus or minus 3, which is where we get that answer, but since the square root was already there, only a positive 3 comes out, which does not equal negative 3. So don't forget to check your answers. This one is so funny. It shows up on the test, and it just terrifies people. Oh my gosh, there's multiple radicals. The world is going to shut down. Guys, look at this. Both of these radicals are isolated. So undo them. How do I undo a third root? Well, if we undo a second root with a second power, we would undo a third root with a third power. What does this leave us with? Well, these cancel, leaving us with 2x plus 7 is equal to these canceling 3x minus 2. Get x on one side. 7 is equal to x minus 2. How about x equals 9? So it's like maybe. Well, technically no maybes on this one. The issue with roots is that with the square roots, we have negative issues. The third roots, we shouldn't have any issue. But still, if you're not sure, check it. 9 times 2 is 18 plus 7. I end up with the third root of 25. So it's like, I'm regretting that we checked this. Okay. Is equal to 9 times 3 is 27 minus 2. Third root of 25. Does the third root of 25 equal the third root of 25? Then 9 is our answer. And this last example it's in the homework. I want you to work through it, but just know that I'm not going to test you on this. There are multiple ways of doing this. It is tempting to look at this and go, oh my gosh, 2 radicals. Maybe I could just square them both, but that is actually not the easiest way. I found that students do a lot better if we at least isolate one of the radicals. So pick one of them that we can isolate. I'm just going to move this one so that it's kind of already on the edge there. So I'm left with is equal to 1 minus 2. Now that that radical is isolated, we can take both sides and we can undo the radical with an exponent. So I'm going to square both sides. This is where things get terrifying. Left side's easy. Those cancel. 2x plus 3. The right side ain't cool because we have 1 minus squared, which is 1 minus So it times itself. And as crazy as this is, as soon as we get this step done, we're going to be pretty close to solving this. So 1 times 1 is 1. 1 times that is minus. That makes minus another one. And then this times itself. Negative times a negative is positive, and it ends up squaring, leaving us with just x plus 1. Basically, the square root of x plus 1 times itself squared just becomes this x plus 1. Okay? Simplify what we can. This poor left side just sitting there, all easy and done. That 1 and that 1 add to make 2, plus x minus, those are like terms, so 2 scarinesses. I want to isolate the other radical now, which means I'm going to minus the 2, minus the x, and get x plus 1 equals negative 2 x plus 1. Now you got a choice. I find that students do better if we just isolate the radical, which means I'm going to divide everything by that negative 2. Even though the left side looks terrifying, I find that they do a little better with the radical on the right side. So x plus 1 over negative 2 ain't pretty. Square root of x plus 1. So now we're going to take both sides and on the top, x plus 1 squared is x squared plus 2x plus 1. On the bottom, negative 2 times negative 2 is positive 4 equals, those cancel, leaving us with just x plus 1. And now I'm going to say, okay, that denominator, now I'm going to multiply that 4 back up. I would have just left the 2 there and squared it and got that 4, but I find that students do better when you get that kind of out of the way, and then we can just bring it back up. So what do we have now? We're almost done, I promise. X squared plus 2x plus 1 is equal to x plus 1. No. Distribute the 4. About 4x plus 4. This is quadratic, so we need to set it equal to 0, leaving us with x squared minus 2x minus 3. And dear Lord, I hope this factors. Let's see. Does this sucker factor? 3 and 1. A minus 3 and plus 1. Setting each group equal to 0. X would equal 3. X would equal negative 1. Good news is we're done with solving it. The bad news is what? I would take these and type them in and hit enter and check it, but let's see. Let's check the 3 first. Let's go back to the original. Way up here. Check x is 3. 2 times 3 is 6. 6 plus 3 is 9. Square root of 9. Plus 3 plus 1 is 4. Does the square root of 9, does 3 plus 2 equal 1? It does not. 3 is not one of our answers. Surely negative 1's wrong, right? Well, let's see. Two times negative 1 is negative 2 plus 3, that's the square root of 1. Plus, negative 1 plus 1 is the square root of 0. 1 plus 0 equals 1. Look at that. Our only answer here is the negative 1. So that's a little trickier, but that's all the examples you're going to see. That last one, I do have, like I said, I think 1 in the homework. I do want you to kind of work through it. I like you to have that challenge. I will not test you on that. So toughen up. We have one section left in this chapter. It's not very hard, so it should be pretty easy to finish this up. Let's finish up strong.